Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 24, and this is the lecture number 2 of Physical Chemistry chapter Liquid State. And the subtopic in this lecture number 2 of Liquid State is surface tension, and this is the first part of surface tension, lecture number 2. And here we are going to have some idea about cohesive force, adhesive force and surface energy. Let's start with these two types of attraction forces, adhesive force and cohesive force. So now some liquid molecules or any kind of molecule, they have kind of attraction force. This may be dipole-dipole interaction, van der Waals interaction, whatever it is, but if the force is a force of attraction, then this force of attraction is of two types. One type is the cohesive force. Cohesive force is actually the force of attraction between two similar molecules. And what about adhesive force? Adhesive force is the force of attraction between two different types of molecules. Suppose, look at this picture. Here is a liquid in this container. So this is some glass made container. Suppose this is a beaker and this is the liquid. Okay. Now this molecule is adhered in the surface of this glass. Here are some silica molecules. Glass is made up of silica. So these silica molecules have some attraction force on these water molecules and vice versa. So this type of attraction force is known as the adhesive force, whereas this molecule is being attracted by this one and vice versa also, or all these molecules are being attracted by each other. So this type of attraction force is known as cohesive force. Now this molecule, they have two molecules which are shaded in black, but they are also the same liquid molecule. These molecules are being attracted by the liquid molecules which are surrounding them. That means the white molecules. Okay, these molecules and the black molecules are same molecule, but this particular molecule, since this is selected, so this is shaded in black, but this is also white molecule. Okay, now this molecule is present in the bulk of the liquid and this molecule is present in the surface of the molecule. Now look, the force of attraction by the other molecules in the surrounding have some resultant vector which is a null vector for the molecule which is in the bulk, because all the attraction forces are being nullified by each other. But here there is no upward pull, so as a result there is a resultant vector which is acting in the downward direction. So that is, these molecules in the surface of the liquid always experience a downward pull, and this is known as surface tension. Okay, let's discuss the resultant attraction forces, which is cohesive in nature. That means the similar molecules on the molecules in the bulk, that is this molecule, it is 0. The molecules at the surface feel no upward pull. So this molecule in the surface, it is feeling no upward pull. That means here is no liquid molecule, so there is no force of attraction, and due to that the force vector towards there is a force vector towards the downward direction, and the surface molecules always experience an inward pull towards the bulk. As a result, the surface of a liquid has a tendency to squeeze and to have a minimum surface. That means, like, consider a balloon. Okay, so what about the surface of the balloon? It's a rubber surface, but when you touch it, you will feel that it is like an elastic body. So there is some tension throughout the surface of that balloon. So same type of tension is working in any type of liquid surface. That means they are very much trying to squeeze themselves. That means they are trying to always have a minimum surface area. That means they are always trying to minimize their surface area, and that is known as surface tension. Now we have to calculate this surface tension mathematically by some exact mathematical procedure. Let's do that. Suppose this is a metal wire. Okay, three sides are there in this metal wire, and this metal wire is the fourth side, but this is movable. With the help of this attached wire, we can move it towards the right hand side or the left hand side. And here a liquid film is made, and this film has two surfaces. One is the upper surface, one is the lower surface. Now if this wear is movable, if this wear is pulled towards the rightward direction, then suppose it is in this position. So some displacement has taken place and some extra surface area has been increased. Let's calculate. The amount of work done in increasing the surface area of a liquid by a unit is called surface energy. So in order to increase the surface area, you have to do some work, and this work is measured, and for every unit of surface, that is per unit surface area, the work done is known as the surface energy. The force acting along the surface of a liquid at right angle to any line of unit length is known as surface tension. So what about surface tension then? Suppose this is the line, okay, and along this line towards the right angle, that means along this direction, from here to here, this direction, from here to here, from here to here, these are all right angled direction from this line, okay. This force of attraction along this line per unit length is called surface tension. Suppose this one has length L, this is the length L, and the force is suppose F, then F divided by L, that means the force per unit length is the surface tension, and surface tension is denoted as gamma. There are two surfaces along L, that means along this wear there are two surfaces, as I have mentioned already. One is the upper surface, another is the lower surface. Therefore the total length of the rectangular film is twice L. And what is the increase in the breadth? This is the increase in the breadth. That means this is the displacement. X is the displacement. So what is the area? Increase in area. Increase in area must be twice L into X, and this is nothing but delta A. If A is the area, then delta A is the increase in area. And if W is the work done, total work done in order to do this, perform this overall work, then work done per unit area according to its definition is surface energy. Therefore surface energy value is W over delta A. So W over delta A, now we have the value of delta A, we know it is equal to twice L into X. So this is surface energy, W over twice L into X. Now if you take this X into the denominator of W, then it becomes W by X over twice L. So in the numerator you have W by X, and in the denominator you have twice L. Now work by length, if work is divided by length, then it becomes force. So it is force, and twice L is nothing but length. So it is force over length, and force by length is nothing but tension, and this tension is known as surface tension, and it is denoted as gamma. Therefore the magnitude of surface tension and surface energy are same. Surface energy and surface tension have same magnitude, although their units are written differently, but dimensionally they are same. How the units are written differently? Look, the unit of surface energy is joule per meter square, isn't it? And the unit of surface tension is Newton per meter. That means energy by surface area and force by length. So it's okay, but look at the dimensional calculation. Joule means energy, so energy means mass into length square divided by time squared. Suppose 1 joule is kg meter square per second squared. Now it is divided by meter squared, that means length squared. So what is left? M by T square. That is kg per second square. Similarly, the unit of surface tension is Newton per meter. Newton means force and meter means length, that is force per length. So the dimension of force is mLT square inverse, that is kg meter per second squared. When it is divided by meter, that is length, then it becomes only m into t to the power minus 2. That means this is the dimension which is same as that of surface energy. Both are m into t squared inversed, that is both have the units kg per second square. So that's all about this first part of surface tension. Thank you and have a nice day.